Good morning. I am Mr. Anand A, Assistant Professor, Rogini College of Engineering and Technology, Department of Civil Engineering, subject CE8602, Structural Analysis 2. Discuss about continuous beams in influence line diagrams. So this is the continuous beam having 5 meter for AB and for BC 5 meter. So in this, any one support you want to assume as a unit force, the reaction is a single unit force. Due to that, what is the influence line diagram? That only want to find the final solutions. So first find the reactions, and before that the conditions. First one, remove the support B, and second, apply a unit load at B. Determine the general deflection YXB at X and the deflection YBB at B. And third one is YXB divided by YBB in the influence line diagram ordinate at any X. So here in figure, this is the influence line diagram for this continuous beam. We are assuming RB is equal to 1, a unit force at RB is equal to 1. So you are getting the normal influence line diagram you want to apply here, and at the two end you want to find the final interval of YXB and YBB. So here the reaction RA is equal to minus 0.5 and RC is equal to minus 0.5. When RB is equal to 1, RA is equal to RC is equal to minus 0.5, using sum of vertical forces equal to 0 and symmetrical. Due to that symmetrical, the two end will be RA and RC is equal to the same value 0.5. And by using the conditions 3 moment, that is EI d square y by dx square is equal to m. And next, by using mx is equal to minus 0.5x plus 1 into x minus 5. Here EI d square y by dx is equal to 0.5x minus x minus 5. Integrating EI d square plus dx is equal to 0.5x square divided by 2 plus c1 minus x minus 5 the square divided by 2. Again integrating, so the first this one is slope equation, and again integrating we are getting the deflection equation, that is EI into y is equal to 0.5 x cube divided by 6 plus c1x plus c2 minus x minus 5 cube divided by 3 into 2. And next, by using the slope equation and deflection equations, you want to find the constant value. For that you want to consider the boundary conditions when x is equal to 0, y is equal to 0, the distances, and the deflection also 0, and x is equal to 10 meter, the deflection is also 0. Hence we are applying this boundary condition, we are getting the c1 and c2, that c2 is equal to 0 and c1 is equal to minus 6.25. Substituting the values of c1 and c2 in the equations for deflections EI y, and next substituting the values of c1 and c2 in the equation of deflection equation, EI y is equal to 0.25 x cube divided by 3 plus c1x plus c2 minus 0.5 x minus 3 cube divided by 3. Yxb is equal to 1 by EI into 0.25 x cube divided by 3 minus 6.25 x minus 0.5 x cube x minus 5 the cube divided by 3. And YBB is equal to, at x is equal to 5 meter, is equal to 1 by EI into 0.25 into 5 cube divided by 3 minus 6.25 into 5 is equal to minus 20.83 divided by EA. And finally, the influence line ordinate for RB is equal to YXB divided by YBB. So I am substituting this YXB 1 by EA into 0.25 x cube divided by 3 minus 6.25 x minus 0.5 into x minus 5 cube divided by 3. So divide by 1 by EI into minus 20.83. This is YBB. And for the influence line ordinate for RB is equal to 1 by 20.83 into 0.25 x cube divided by 3 minus 6.25 x minus 0.5 x minus 5 cube divided by 3. This is the final deflection equations. By using these conditions, you want to apply the intervals for 1 meter and you want to find the influence line ordinates. And for x, support C 0 1 meter, the RB is 0.296, and for x 2 meter 0.568, and for 3 meter the RB is 0.782, and for RB is 0.994, and support B 5 meter 1, and for 6 0.994, and for 7 meter 0.782, and for 8 meter 0.568, and 9 meter 0.296, and support at A 10 meter 0. So like this, the difference intervals we can change for 2 meter intervals, or we can take 3 meter intervals, such a which one is possible we can apply it. So this is the influence line diagram for RB. And finally, by using these values, so you want to plot the diagrams at this in a continuous beam span AB 5 meter, BC 5 meter. So you want to find the influence line values, that one you want to mark at the top of the beam. This is the deflection diagram, or you can say it is the influence line diagram. Thank you.